Welcome to the Executive Spotlight Q&A, a sponsored Light Reading audio production. I'm Phil Harvey. I'm an editor here at Light Reading, and today's Executive Spotlight features Bill Gartner. Bill is the Senior Vice President and General Manager of Optical Systems and the Optics Group at Cisco. We're going to talk about optics. We're going to talk about optical networking and how the two relate to each other and come together as it relates to Cisco's business. We'll talk about some of the investments that Cisco has made in optics over the years and why those investments are key to the shape that the business has taken now. We'll also talk about Cisco embracing trends like disaggregated optical networks, 400GE, and new shifts in architecture, like what used to be called IP over DWDM, and how that sort of evolved over the years, and how Cisco has caught a couple of technology trends, made some savvy acquisitions, and is now in a position to not just serve its customers on the telco side, but also on the hyperscale cloud data center side as well. And also just be, in general, a much more flexible company, both in the optics and the optical networking domain. So we'll be talking about all of those optical issues with Bill Gartner at Cisco Systems, and we'll get to it right after this. Welcome to the Executive Spotlight Q&A, a sponsored Light Reading audio production. I'm Phil Harvey, and on the Executive Spotlight today, joining me is Bill Gartner, the Senior Vice President and General Manager of Optical Systems and the Optics Group at Cisco. Hi, Bill.
Hey, Phil. Thanks for having me.
Thanks for being on. I really have been looking forward to talking to you, and I have, I think, a very relevant question because it's right there in your title. So you've got optics and optical in the same title, and you're in charge of both. So what exactly do you mean by optics versus optical? Let's clear that up.
Yeah, that's a good place to start. When we talk about optics, what we're referring to really are the technologies that are deployed inside the four walls of a data center or a central office, and that world is characterized by a couple of attributes. One is that fiber is plentiful, meaning if you add a new switch or a new router, you pull new fiber, and every port gets its own fiber. So that's one signal per fiber. And the other attribute is that the distances are short. In this world, short is less than 10 kilometers. And that technology is typically direct detect, which means if the light's on, it's a 1, and if the light's off, it's a 0. And that's when we're talking about the transceivers that are deployed in switches and routers for that application space of fiber being plentiful and distances being short. We're talking about optics. Now, when we leave the data center or the central office, now we're in a different world where fiber is scarce, meaning if a customer puts a router in New York and another one in LA, we can't very well ask them to drop new fiber between New York and LA because that's a multi-billion-dollar problem. So in that sense, fiber is scarce, so we need to leverage technologies like DWDM to put as much capacity as possible onto the existing fiber. And the other attribute is that the distances are long being certainly more than 80 kilometers, up to several thousand kilometers. And for that technology, we need something that's more sophisticated than direct detect, and we rely on coherent DWDM technology. And whereas the technology finds its home in a transceiver, pluggable transceiver in the optics world, it's classically found its home in a chassis-based solution in the optical systems world. So the two worlds are related by the fact that both rely on light traveling over fiber, but very different applications and some very different challenges. And then as we talk about a little bit more, when we see things like the ZR technologies emerging, that kind of blurs the distinction because now we're putting a coherent DWDM pluggable directly into a router or switch. So that's kind of how we think about the two worlds.
So the two worlds are coming together eventually in certain applications.
Yeah, for certain applications, right.
Okay. On the optics part, so why should customers consider using Cisco Optics? I'm not exactly sure how long Cisco Optics has been part of Cisco, either as a business unit or sort of in general. But what's the advantage that you have in the market?
Yeah, so Cisco Optics is a very integral part of Cisco and a very substantial business that we don't break out revenues, but we sell over 10 million transceivers per year and have a full portfolio from 1 gig to 400 gig, really satisfying any application, whether it's a campus application or a long haul application. Our field quality is just exceptional, less than 100 parts per million return rate. And I think some of the things that are unique about Cisco is we we have a breadth of suppliers that we rely on, whether it's component or whether it's a transceiver, so that when there's a disaster that occurs, whether it's a natural disaster or an economic issue, Cisco can generally respond to that very quickly for our customers, and they're not stranded by a problem that exists in one part of the world or in one economy. And then I think another thing that's really important about Cisco is we bring systems level expertise. And we've certainly seen at 100 gig and now 400 gig, many of the problems that we took for granted at 1 gig and 10 gig as just being interoperable and very easy to make a host interface work. Those get much, much more complicated as the bit rates increase. And Cisco
Mm,
brings that switch and router expertise. As part of qualifying any optic, we do design verification, optical, electrical, mechanical. We do compliance testing, and we do cross-platform testing. So we make sure that it works in a variety of platforms, including Cisco platforms as well as third-party hosts. So when we have a Cisco optic that we sell to a customer, we guarantee it's going to work in any platform, whether it's a Cisco platform or a third-party host.
yeah, that's a good point too about the physical challenges kind of becoming more and more pronounced as you get into higher and higher speeds, and then longer and longer distances. Um, it does seem to create an environment where you definitely better be sure of what you're putting out there in the market.
No, no question. And just to expand on that a bit, when we deal with a lot of suppliers in the industry, we build many of our own transceivers, and what we see consistently is that people who think that things are compliant with standards or that will work under all operating conditions are very often wrong. They have not tested against corner cases like temperature and voltage variations and different host environments. And now what's happening is many of our customers are actually bearing the brunt of having to figure that out. So when we put a Cisco label on an optic, we are basically bearing that responsibility ourselves. And it's non-trivial at 100 gig and beyond.
Let's talk about some of what makes up Cisco Optics. So, what investments has Cisco made in optics, and why are those investments important?
Yeah, so you asked a little earlier, like how long we've been doing this. We've been doing this I've been with Cisco for a dozen years, and we've been doing it longer than I've been here. But our initial investments in optics really started with Core Optics when we acquired sort of a first generation coherent technology.
Mhm.
And that was followed by an acquisition of Lightwire, which was a first generation silicon photonics technology. And more recently, last year, we acquired Luxtera, which brings us sort of a next generation silicon photonics platform that really, I think, delivers on the promise of silicon photonics, which is to make the optic look very much like an ASIC. And the industry is not there yet in terms of having everything in the optic, but
Right.
Luxtera captured most of the optical problem in an ASIC. And importantly, they adopted a mindset from day one that it had to basically follow like a CMOS manufacturing process,
Hmm.
which is basically everything is automated. You automate everything from wafer scale through module test because you can't afford to have human interaction there and then drive the costs down and drive the yields up. So
Hmm.
Luxtera brought a highly automated manufacturing platform that really allows us to scale. And then we announced the acquisition of Acacia for coherent technologies, but also for the fact that Acacia has done, I think, a phenomenal job in bringing together not only coherent DSP technologies, but also silicon photonics and packaging those in a way that really do enable things like ZR pluggables.
Okay. Yeah. So there's some key pieces in kind of an overall, I guess, optics discipline. I want to refer back to something we were talking about earlier about IP over DWDM and kind of pluggables going directly into routers and switches. Uh, so that's been kind of a topic for conversation as as the worlds of optical and optics have evolved and kind of seem to be converging at a point. Is Cisco planning an architecture around that development? And since I guess since I use the term IP over DWDM, it's been something that people have talked about in the industry forever. Is this the same thing that's finally coming true, or is there a little bit, is a little bit a different variation happening here?
Yeah, no, it's a great question. IP over WDM was basically an innovation that really started over 10 years ago, where the effectively the transponder that was part of the optical system was incorporated into the router, so that instead of having a short reach optic in the router that connected to a short reach optic in the optical system that then converted that to a DWDM optic, you
Hmm.
take the DWDM optic and put it directly in the router. And it seemed like a good idea. The problem with that was, and part of the reason I think it did not succeed more broadly as a deployment methodology, was that it required a significant density penalty on the router.
Hmm.
You couldn't take that short reach host interface on the router and basically plug a coherent interface into it, whether it was on board or whether it was a pluggable, without incurring significant density penalty. And even with improvements over time, as recently as last year or two, there was still a 3-to-1 density penalty. Meaning, if you took a 3.6 terabit router blade and said, I want to have this be DWDM instead of short reach optics, you would take that 3.6 terabit router and convert it to a 1.2 terabit router blade. And
Hmm.
that density penalty was actually okay for some customers, but for many customers that looked at the router and said, look, I've effectively paid for slot capacity. I'm not willing to give up that capacity in the form of a density penalty. So that was one problem. And another problem was that there were operations challenges, and there was some religion around this, like the IP world versus the optical world, and that DWDM line card that you could plug into a router was actually a dedicated line card, so it required its own planning and operations, and the customer had to be able to anticipate when they would need DWDM versus short reach and which ports, and so there were some operations challenges there. And then I would say um, one sort of more subtle, nuanced issue was that the optical world and the routing world, for many customers, had different life cycles. The routing domain had a shorter life cycle in many cases, and there was a longer life cycle in optical. It would sit in the network 10, 15 years. And you're
Hmm.
taking the most expensive component from the optical world and moving it into the router world that you're now going to recycle faster. So there was a question about whether the total cost of ownership really made sense. So those are all challenges in the IP over WDM world. Now, I think you have to ask what's changed here. And I think, broadly speaking, two things have changed. One is that we now, for the first time ever, have silicon in routers, like the packet processing silicon, that actually exceeds the anticipated traffic demands. So we actually have routers now that, when we do modeling with customers, that router may be satisfying their full demand for the next 5 to 10 years, whereas that's never been the case in the past. We always
Hmm.
sort of expected to have to intersect again with a new next generation silicon. But what that means is that there's effectively excess capacity in the router. And the question is, can you take advantage of that? And at the same time, with the emergence and of ZR optics, where there is no density penalty, zero density penalty, that ZR optic can be plugged into a router just like a short reach optic. So it eliminates the whole issue of density penalty that IP over WDM suffered from. It minimizes the operations issues because it largely speaking is standardized, and so it's not quite plug and play, but it's getting very near plug and play for certain applications anyway. So those two things, when you start to look at those two things, one is you have excess capacity available in the router, and secondly, you're now able to take advantage of a DWDM pluggable that goes into the router. Now you have to ask, hey, do these two things allow us to rethink how networks are actually built? And we think the answer is yes. At least for some applications, we think that we can take advantage of that excess capacity and actually do things like, well, let's use the router to switch private line services. Have effectively the packet layer be the only layer in the network, as opposed to thinking about a packet layer plus an OTN layer plus a DWDM layer, all of which are doing switching, all of which have their own control plane, all of which have their own operations. Let's think about the packet layer now as being able to carry that private line traffic as well as the TDM traffic and do it in a cost-effective manner. And in many cases, use that packet layer as the layer that would be switching wavelengths, but do that at the IP layer rather than at the wavelength layer. That's an architectural shift that we believe has significant value for customers, and one we're talking with customers about now. Just to be clear, we don't call that IP over WDM because IP over WDM really has, I think, a lot of those negative connotations associated with it. We're calling that routed optical networking.
Okay. Yeah, thanks for clearing that up. That's a good overview of what's happened in the network since the technology's evolved. So now let's talk about disaggregated optical networks. And I guess disaggregation's happening, in many places within telecom and internet networks. It's happening in the routing space. It's happening in the edge. Are you seeing more of this in the optical networking domain, and how do you see that sort of taking place?
I would say that I think it's been a mixed bag. We have some customers who are fully committed to disaggregating portions of the optical solution or portions of their network more broadly. We've had some customers who have tried it and have decided it's a lot of work and maybe I shouldn't be in this business of doing this myself. But what Cisco did actually back in December is we had a launch called the Future of the Internet, and
Mm-hmm.
we announced an intent to offer customers technology in whatever form they wanted to consume it. So we're not going to second guess our customers. We're not going to try to persuade them that they're heading down a difficult path. If a customer wants to consume technology in a fully integrated system with hardware and software baked in and network management, we're happy to offer that. But if that customer says, look, I really want to buy your silicon and build my own stuff, my own router or switch, for the first time ever, we're going to offer customers their silicon and they can go build their own. And similarly, we do that with software. So we have some customers who are actually taking our routing software and deploying it on their white box solutions. And with optics, customers may decide, like, I'm going to use a white box solution. I'm not going to use a Cisco switch, but I would like to use Cisco Optics for all the reasons that I cited earlier. And so we are going to offer customers fully integrated solutions. We're going to offer them modules like an optics transceiver or chipsets. If a customer wants to buy a photonic integrated circuit or wants to buy a switch or router silicon, we're going to offer that. So I think for a long time we second guessed our customers and said, look, that's difficult. It's really hard for you to do that. And I think we've come to the realization that our customers really know what's best for them, and we're gonna offer them technology in the way they like to consume it.
That certainly makes sense. Okay, last tech trend is 400 gigabit Ethernet or 400 GE. We've been talking about that for a couple of years, mostly in relation to the cloud service providers. It's, who are building cloud scale data centers. Do you see that becoming a bigger force in the marketplace, both, in the cloud, but also in the traditional telecom network as well?
Yes, I do, and I would caveat that and say eventually.
Okay.
There's not been a massive deployment of 400 gig yet, in part because the technology hasn't really been mature enough to support that. There is always a chicken and egg problem with a transition technology of when do the price points make sense, and the price points make sense when the volumes are achieved, and
Right.
so that's the chicken and egg problem we always have to deal with.
Yeah.
I would say, though, that I don't think anybody should think 100 gig is sort of a transition technology. I think 100 gig is going to be around for a very long time. We still sell a ton of 10 gig. And if you think about, 10 gig has been around for over 20 years now. And I do believe that 100 gig is going to be the building block for many, many customer networks for a very long time. But we certainly will see a transition to 400 gig. And that transition will take place starting with things like DR4, 400 gig DR4 and FR4. And that will then necessitate an upgrade in some cases on the 100 gig optic, because a DR4 running at 400 gig has 4 100 gig fingers or 4 100 gig lanes that come out.
Mm-hmm.
And they have to connect to something on the other end. And the question is, what do they connect to on the other end? And they connect to 100 gig FR or DR optic, which is really kind of a second generation, because what's been deployed largely in customer networks for 100 gig to date are things like CWDM4 and PSM4. And what really is required to mate with a DR4 is 100 gig FR or DR. So it's a single wavelength as opposed to multiple wavelengths like CWDM4. So I think there will be an upgrade cycle on 100 gig that we'll see in many applications. There will be continued deployment of things like CWDM4 and PSM4 for customers that are happy building that out. And we will see 400 gig. I think data centers are ripe for 400 gig deployment, but I don't think anybody should be predicting the end of 100 gig, because it's going to have a very, very long tail.
Yeah, I think that's a good way to look at it too, because it does sort of, this stuff does take a while to not only get out into the market, but I guess sometimes we get carried away with the leading edge and assuming that because it's the latest and greatest that it's also cheap enough for everybody to buy in volume.
Right, exactly.
Okay, well, Bill Gartner, thanks so much for taking the time today and walking us through all those optics and optical trends, and we really appreciate you being on the Executive Spotlight Q&A.
Thanks again, Phil. Enjoyed being here. Thank you.
That is it. That's our show. Special thanks to Bill Gartner at Cisco Systems for his time and insights today. As noted before, this is a sponsored audio production, and the Executive Spotlight does not necessarily reflect the views of Light Reading's editorial staff, although sometimes it does. To schedule your own Executive Spotlight Q&A, please do contact the Light Reading Sales Department. The email address there is sales@lightreading.com. Thanks for listening to the Light Reading Podcast.